Hello friends, in our last video we had discussed about the rules of block diagram analysis, and in this video we'll be solving one such example of block diagram analysis. So this is the problem and we need to find out the transfer function, that is the total transfer function of this whole system with the help of block diagram analysis techniques. Now let us see how to begin with it. You can begin with it from any way, like let us say we can bring this block, we can bring this summing point before, we can bring this point before, we can bring this takeoff point before, we can do it any ways. What I am showing is the way that I felt is the easiest. You can do it in any way, and be rest assured that in every way that you'll solve, you'll get the same answer every time. So let us start this. So here the first step that I'm trying to do is bring this takeoff point here. Now I'm not doing it just for the sake of it. There needs to be a reason for this. If I bring this takeoff point here, these two blocks will be just in parallel. So we can get an equivalent model for these two blocks, and then we can think about what we'll do with the next block. So let's do this first. So the first step that I'm trying to do out here is putting this as it was. This will be my G1, this will be my G2 as it was, right? This will be the summing point, this will be my C, this will be my H2, this will be my H1. These are just not changed, this will just go as it was, right? This will be the summer, and this goes here as a negative feedback, right? So what about this thing? What about the G3 out here? The G3 was here. So if I put this block out here, that is if I move the takeoff point beyond the block, so what happens? It gets divided as we see. So it becomes G3 by G1 because we have moved it in front of G1 block, so it becomes G3 by G1. A summer with G3 by G1 means these two are in parallel. So the next diagram that we can get from this is directly, this is G1, this is parallel means adding, that is my G2 plus G3 by G1 directly. This is my C, from here I get my H2, from here I get my H1, right? These two are summed up and goes into the negative feedback, right? So the next thing that we have to do is, so the next thing that we do out here is that we can move this takeoff point, that is we can move this takeoff point beyond this block. If I move a takeoff point beyond the block, we just know how it works. That would be just divided by the block gain. So let us do it in this way, and I'll show you how I did it. So this was the last equivalent model that we had. Now making the model out of this, we will get this as my summing point. This will be my G1 block, this will be my G2 plus G3 by G1 block, this is my H2 block, and this is a summer, and we want to bring that takeoff point out here. So what will happen to the takeoff point right now? The takeoff point was out here, right? In this block it was out here. Now I move it out here. So what happens to this block? This block, what happens is that it will be divided by this block gain. That is H1 would be divided by G2 plus G3 by G1, and this is added, and then it goes to the negative feedback, right? Now these two are in series, so as we definitely know, it will be multiplied directly. So multiplying G1 and this whole thing, taking the LCM, it becomes G3 plus G1 G2 by G1 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 gets cancelled, so it just becomes G3 by G3 plus G1 G2, right? So from the earlier diagram here we can find out the next diagram as this would be my feedback point, this would be my multiplication of that thing. That so it is G1 G2 plus G3, right? Here it comes out here, and this is my H2 and this is my H1 by, so we can just do a LCM and we can get G1 H1 by G1 G2 plus G3, G1 G2 plus G3, right? Doing a summing point out here and putting it to the feedback, right? So summing point out here directly means that these two blocks are in parallel. So adding these two blocks, we get the final diagram as this. This would be my G1 G2 plus G3, and this would be my block where those two are in parallel, so that will be added. These two will be added, so it is G1 H1 by G1 G2 plus G3, this plus H2, right? And that goes in the feedback block, negative feedback. We can directly solve this by using the formula that is for a closed loop system. What is the formula? That is G by 1 plus G into H. We can use that formula and we can solve it very easily. So doing that, let's solve it. It is G1 G2 plus G3, which is the current G out here, that is G by 1 plus GH, right? That is G by 1 plus GH. So as it becomes, it is coming like this is my G by 1 plus G, which is my G1 G2 plus G3 into my H. What is my H out here? H is this part, that is G1 H1 by G1 G2 plus G3 plus H2, that is G1 H1 plus G1, that is plus G1 H1 plus H2 by G1 G2 plus G3, G1 G2 plus G3. That is the current thing that we are getting. Taking an LCM, we can easily get G1 G2 plus G3 by 1 plus G1 G2 plus G3 into, taking this LCM, we can get G1 H1 plus G3 H2 plus G1 G2 H1, right? By, this would be G1 G2 plus G3. So this gets cancelled from here and we get the final answer out here, which is equal to G1 G2 plus G3 by 1 plus G1 H1 plus G3 H2 plus G1 G2 H2. Okay, so this is the final transfer function that we obtain out of this whole block diagram analysis. So let us check this. We had given this sum from the book of Mankey. So this is the sum that we were doing and we had got the final answer in the book, that is equal to my G1 G2 plus G3 by 1 plus G1 H1 plus G3 H2 plus G1 G2 H2. So we have found out the final answer from the book, which is equal to the answer that we have found out right now. So the answers have matched and so we have done it right. Thank you for watching.